Hello everybody and welcome to this session on HCF and LCM. Fairly simple ideas. So it's going to revolve around the topic of factors versus multiples. And once you understand what factors are and what multiples are, understanding this topic is going to be fairly simple. All right, so who do we have here with us? Aditya Chauhan. Hello, my friend. We have Sumit. Good evening. Hi. Shweta. Hello. Kritika. Dhruvi. Hi. Anukriti Patel, hi. Sumit, hello. All right, thank you Shweta for letting me know that I'm perfectly audible and visible and saving us quite a lot of time. Thank you so much for that. Hi Tanushri, hi Maria, hey Pritam, hey Mukesh. All right, so we are perfectly audible and visible. Krishna, hi. Sunidhi, hello. Legend, hi. All right, so come on, let's begin the session now. As I said, it's gonna revolve around two very important ideas of factors and multiples. All right, so but before that, I've got to let you know about the Byjus premium classes. And as I say, the strength of the program lies in the fact that one-to-one attention, instant doubt solving, concepts are being taught by the expert teachers out there using all the visuals, the animations and whatnot, and personalized extra classes would be given, one-to-one guidance, and you can choose your own classes, and the fact that they are mapped to your school curriculum. The link to all of these would be there in the descriptions box. Make sure you give it a try. And then you also should be knowing we have a Telegram channel. Again, the link to this could be found in the descriptions box, and make sure you join the channel because session notes with the tutor's handwriting would be shared only on the Telegram channel. All right, so come on, let's begin the session now by first developing an understanding of what factors and multiples are. Now, if I take the example of 16, what are factors of 16? Factors of 16 are going to be these, because by definition, if we were to understand what factors are numbers which are perfectly divisible. Okay, like let's suppose 16. Any number is going to be divisible by 1, right? 16 when I divide by 2, 2 times 8, 16, and as you can see here, the remainder is 0. But the same 16 when I try to divide it by 3, this is 3 times 5, 15, and as you can see, the remainder is 1. Thank you, Shweta, for inviting the friends to your class. The more number of students, the better it is, always. All right. So this is the reason why, since 16, when I divide it by 3, the remainder is 1, we say that 3 is not going to be a factor of 16. But 4 perfectly qualifies, right? 16, when I divide by 4, 4 times 4, 16, and as you can see, again, the remainder is 0. So when a number is divided by its factors, the remainder is 0. Okay, again, 5 is not going to be a factor as well, because 16 when I try to divide it by 5, as you can see, 5 times 3, 15, I am getting a remainder of 1. So likewise, if you try to figure out the factors of 16, these are going to be the factors 1, 2, 4, 8, 16. Okay, so we understand what factors are, right? Now, let's go ahead and understand what multiples are, because these are, as I said, the two most important keywords. Yeah, so the 5 times table, like 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15. All of these numbers that you see here, right? 5, 10, 15, 20, 25, 30, 35. All of these are going to be called multiples of 5. Okay? So you've understood what factors are and you've understood what multiples are. Let's just take some other example as well. Let's suppose I ask you factors of 24. What are factors of 24? Factors of 24 are going to be what? 1 is always going to be a factor. So because every number is divisible by 1. Then 2 is also going to be a factor, because 24 when I divide it by 2, it is perfectly divisible. The remainder is 0. Yes? So 2 is going to be a factor. This time 3 is also going to be a factor. 4 is going to be a factor, but 5 will not be a factor, because 24 when I divide it by 5, this is 5 times 4, 20, and as you can see here, the remainder is not 0. The remainder is 4. So 5 is not a factor, 6 is a factor, 8 is a factor. In a similar way, 12 is a factor, and 24 is a factor. All right, so these are factors. Well done. Ayush and Mukesh, you guys have given the answers. So very good. Good evening, Anya. Okay. Dhruvi says, I have a doubt. Every number except prime numbers have factors. Even prime numbers have factors, Dhruvi. Prime numbers have two factors. Like 2, their two factors are 1 and 2. Every number is going to have a factor. All right? It's just the number 1 which is only going to have 1 factor. So all the other numbers are going to have a minimum of 2 factors, as you will see. All right. So these are all the factors of 24. Okay. Now, if I ask you multiples of 3, let's say multiples of 3. What are you going to say? Multiples of 3 means what? You're going to tell me the 3 times table. 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, 3 times 6 is 18, and the list is going to go on and on. Yes? Yes, Anukriti, prime factorization is something that we are going to cover in this session today. Gulleen says, what is a twin prime? Okay, Gurleen, I'm going to answer your question here. Answer it when we are discussing prime numbers. Okay, it's going to happen in today's session. Just remind me then to answer what a twin prime is. It's a fairly simple concept. Okay, so we've understood these two very important things. We've understood what factors are. We've understood what multiples are. Right? Now, let's observe a few points with respect to factors and multiples. Okay, like if you observe, every number except 1 will have minimum of 2 factors. 1 and the number itself. Minimum 2 factors will be there for every number except 1. 1, it's only going to have 1 factor. The factor of 1 is only 1. But all the other numbers, minimum 2 factors will be there. Like factors of 2 are what? 1 and 2. Factors of 3, 1 and 3. Factors of 4, 1, 2, 4. Factors of 5, 1 and 5. Factors of 6, 1, 2, 3, 6. Okay, you can also check it out. You will observe that the number 1 will only have 1 factor, that is 1 itself. All the other numbers are going to have a minimum of 2 factors. Okay, co-prime numbers also, Dhruvi, I'm coming to that. All right, when we are discussing prime numbers, I'll tell you what co-prime numbers are and what you had some twin prime numbers are. Okay, so this is it. And factors, these are some important points that you should know with respect to factors. First thing is that they are smaller or equal to the number. A factor cannot be bigger than the number itself, right? Like if I take the example of 6, the maximum factor for 6 is going to be 6 itself. You will not be able to have factor like 7, 8, 9, 10, all of that for a number 6. So factors are always smaller or equal to the number, and factors are finite, which means you can count the number of factors. In fact, if you remember, we also did one session where we learned how to count the number of factors a number have using the technique of prime factorization, right? But when it comes to multiples, multiples are always greater than or equal to the number. All right, like multiples of, let's say, 4. Multiples of 4 are going to be what? Multiples of 4 are going to be 4 times 1, 4, 4 times 2, 8, 4 times 3, 12, 4 times 4, 16, and you know they go on and on and on and on. If I ask you how many multiples of 4 are there, you're going to say they are infinite multiples of 4. If I ask you how many multiples of 7 are there, you're going to say 7 has infinite number of multiples. Multiples do not end. That's the reason why multiples are infinite. Okay, and they are greater than or equal to the number. Whereas when it comes to factors, factors are finite in numbers. And I recall this again, you have learned a technique where you've learned how to count the number of factors for big numbers using prime factorization. And factors are smaller than or equal to the number, right? Yes, there is no end for multiple. Very good. All right, so we will come to that in the end. Okay, now let's do a little exercise to just understand whether you've understood factors or multiples or not. Okay, now you've got to tell me for these numbers 51, 21, 25 and 26, what are the factors and what are the multiples? So let's start with the number 51. Come on, tell me what are factors of 51. Arka, what is a perfect number? I'm coming to that as well. Oh boy, you guys know what we are going to do in today's session itself. Yes? Okay, we are coming to perfect numbers, we're coming to twin prime, we're coming to co-prime, we'll check everything out. Okay, so come on, tell me what are factors of 51 and multiple of 51. From these options, you guys have given the correct answer, but from the options that you have here, okay, like Shweta, you have given the correct answer, like 1 is a factor, 3 is a factor, 17 is a factor, but from these options, 17 is going to be a factor for 51, and what is the multiple going to be? Out of these, multiple is going to be 153. For 51. You've understood what I'm trying to ask you now, right? Come on. Now tell me similarly for 21, what is the factor and what is the multiple out of these options? All right. Like 21, is it divisible by 13? No. Is 21 divisible by 5? No. Is 21 divisible by 7? Yes. So 7 is going to be a factor for 21. Very good. And in a similar way, what is the multiple? 75 is not a multiple. 78 is not a multiple. 84 here is going to be a multiple for 21. Okay, Maria says she does not understand. Maria, look, we are simply trying to understand factors and multiples. Factors are what? Perfectly divisible, like factors of 15. 1, 3, 5, 15. These are going to be factors. 2 is not going to be a factor because 15 when I divide by 2, as you can see here, the remainder is 1. But when you are dividing a number by its factor, the remainder has to be 0. Like when you divide 15 by 3, the remainder is 0. When you divide 15 by 5, the remainder is 0. That's what factors are. I hope you've understood this now. Okay, 25, fairly simple. The factor is going to be 5 and the multiple is going to be what? 75, right? And lastly, for the number 26, 13 is going to be the factor and then 78 here is going to be the multiple. All right. And we've seen some other points with respect to factors and multiples as well. Let me just rearrange all of this. So this way you understand the factor and the multiple for a respective number. Yes, Ayu, 75 is a multiple of 75. Very good. It also happens to be a factor for 75. Yes. So first step, what have we done? We've understood the definition of what factors and multiples are. I want to repeat it again for students who have still not understood. Look, factors. Divide the number without a remainder. Without a remainder. Or when you divide a number by its factor, the remainder is 0. Let me just say remainder is 0. When a number is divided by its factor, the remainder is 0, right? And multiples are the table, times table. Multiples times table. Like 5 times table, 7 times table, 8 times table, all of these are going to be multiples of 7. A number is a factor and also a multiple of itself. Yes, Dhruvi is asking good questions today. All right, come on. Now I will answer your questions, but I have a question for you to just make sure again you've understood all of these things. Let's see what the question is. The number 84 has all the following factors except what? So you have to decide the number which is not a factor of 84. 30 seconds would be given and the time has started. So a poll has been given to you there. You can check that out. Which of the following options is going to be correct? Okay, answer it in the poll, guys, so that we know what percentage of students have answered the correct one. So the number 84 has all the following factors except which one? So you have to decide the number which is not a factor of 84. So far 79% of you, 81, the number has moved up now. Okay, so time is up. 81% of you say it is option B, and well done, majority is correct here. So 84 is going to be divisible by 4. All right, look, 84 when I divide by 4, this is 4 times 21, 84, the remainder is 0. So 4 is a factor. 84 when I divide it by 6, this is 6 times 14, 84. Again, the remainder is 0. So 6 is also a factor. But 84 when I divide it by 5, this is 5 times 16, 80. And as you can see, the remainder is 4. Unlike others, the remainder is not 0. So that's the reason why 5 is going to be the correct answer. So all of these numbers are factors except 5. All right, come on. Moving on to a new concept now. This time, before we jump into the technique of prime factorization, let's first understand what prime numbers are and what composite numbers are. All right. So first thing, prime numbers. And as you know, prime numbers are what? They only have 2 factors, right? One is any which way is a factor for all the numbers. The second factor that these numbers have is going to be the number itself. Like what are factors of 2? Factors of 2, 1 and 2. Factors of 3, 1 and 3. Factors of 5, 1 and 5. Factors of 7, 1 and 7. All right. So every prime number is only going to have 2 factors, 1 and the number itself. Okay. Aditya, increase the sound. Okay, we are perfectly audible, I believe. Yes. So numbers which have only two factors. Yes, Ayush. So they are going to be your prime numbers. Okay, they have only two factors. One, which is anyways a factor for any number. The next factor is going to be the number itself. Okay, like 11 is also a good example. 1 comma 11, just two factors. 13, 1 comma 13, just two factors. Okay. Composite numbers are opposite of prime numbers. Now these are numbers which have more than two factors. All right. Like for example 4. How many factors will 4 have? 4 is going to have three factors. 1, 2 and 4. That's a reason why 4 is the first composite number. Okay. And if you remember, 1 has only one factor. So therefore this is an important bit for you to remember. Okay. 1 is neither prime. 1 is also not composite, because prime numbers should have two factors. Composite numbers should have more than two factors, right? So the first prime number is 2, and this number 2 also happens to be the only even prime factor, all right? And these are composite numbers, like factors of 6, 1, 3, 1, 2, 3 and 6. Factors of 8, 1, 2, 4 and 8. So as you can see, all of these composite the numbers are going to have more than two factors. One is neither prime nor composite. Very good. Very good. Now, I'm sure you've understood the definition of what prime numbers are and what composite numbers are. Now, I'm going to answer your question. I believe who asked that question? It was Dhruvi, right? Dhruvi, what was your first question? Your first question was what? Co-prime numbers, right? Co-prime numbers. Okay, let's understand what co-prime numbers are. Co-prime numbers are numbers which do not have any common factor other than 1, because you all know 1 is going to be a factor for every number. So other than 1, these numbers do not have any common factors. Like if I were to give you an example, 4 and 9, these are co-prime, right? Because what are the factors of 4? 1, 2 and 4. What are the factors of 9? 1, 3 and 9. Other than 9, do you see any common factors between 4 and 9? You don't have any common factors, right? Other than 1. So that's the reason why 4 and 9 are called co-prime. So these are co-prime. That's the reason why I'm putting a tick mark here. Let's suppose I take 3 and 12. All right. 3 and 12 are not going to be co-prime, right? Because what are factors of 3? 1 and 3. Factors of 12? 1, 2, 3, 4, 6 and 12. So other than 1, they also have a common factor of 3. Okay. Yes, Gurleen, I'll come to your question as well. A twin prime number. But have you understood what co-prime numbers are? Yeah. Gurleen, look, co-prime numbers are numbers which do not have any common factor other than 1. Like 4 and 9. Look at this. What are factors of 4? 1, 2, 4. What are factors of 9? 1, 3 and 9. Yes. So other than 1, do you see any factors which are common? No common factors, right? That's the reason why we say 4 and 9 are co-prime. In a similar way, 3 and 12 are not co-prime, because other than 1, 3 is also the common factor between them. All right. So 3 and 12 are not co-primes. So we've understood this. Yes. 2 and 3 are co-primes. 5 and 11 are also co-prime. Very good. So easy concept. Yeah. Now coming to the fact that what are twin primes? Twin primes are numbers like 2 and 3, right? Or 3 and 5, something like that. 5 and 7. Difference is 2, I believe. Perfect numbers. When you add the factors of perfect numbers, okay, let's take an example. What are factors of 6? 1, 2, 3 and 6, right? What happens when you add up all the factors? 1 plus 2 plus 3 plus 6. What do you get? You get 12. Right? When you add up all the factors of 6, you get 12, which is double the number, right? This 12 is double the number. So that's the reason why we say factors only twin prime factors come in pairs, not every other. Not every other factors come in pairs. Okay? Now you've understood what perfect numbers are. Look, 6 is called a perfect number because when you add all the factors of 6, the result is double the number itself. Is that clear now? Yeah? All right, come on. Let's move on now and check out these questions, prime numbers, composite numbers. So you guys look at the list and tell me what is prime and what is composite. Remember this, prime have only two factors, one and the number itself, and composite numbers have more than two factors, of course. Okay, come on, first answer this question. All right, so we have answers coming up. Apologies for that. What are prime numbers? Okay, prime is what? 13, 11, and 17. 13, 11, 17. So these are going to be your prime numbers. And the remaining ones, of course, are going to be composite. Like 26 is going to be composite. 38 is going to be composite. 42 is going to be composite along with 39 and 48, because these numbers here are going to have more than two factors, whereas prime numbers are only going to have two factors. Very nice, very nice. So far, do we have any questions? We've understood what factors and multiples are. Very good. We've understood what prime numbers, composite numbers are. Very good. We've understood like some of your questions, right? What were those questions? We've understood what perfect numbers are. We've understood what co-prime numbers are. And we've understood what twin prime numbers are. Twin prime numbers are what? Very simple. You know, difference should be 2. That's it. Like 3 and 5 are twin primes. The difference is 2. What other numbers are twin prime? 5 and 7 are twin primes. What else? 11 and 13 are twin primes. Okay? Do factors always come in pairs? Yes, of course. Factors are always, except for one. Except for one. 1 is the only number which has one factor. All the other numbers are going to have minimum two factors. That's what I'm sure you mean by a pair. Pair means 2. Yes. Very good. Poll question. All right. Let's see if we have any poll questions. I don't remember. All right. So moving on from this, coming to the most important part of the session, which is going to be prime factorization. So please make sure you focus and understand this. All right. So prime factorization means writing factors only using prime numbers. Like what are prime numbers? I'm going to write all the prime numbers down first. 2, 3, 5, okay, 2, 3, 5, 7, 11, 13, on and on and on and on, infinite prime numbers. Let's take an example. Let's take the example of, let's say, 108. I want to prime factorize 108. The first step is to check if 108 can be divided by the first prime number. What is the first prime number here? 2. So let's see if it can be divided by 2, which I'm sure it can, right? So 108, when you divide it by 2, I get 54. Very good. Now 54, again check if it can be divided by 2. It can be, right? So 54, when I divide by 2, I get 27. All right. Now 27 cannot be divided by 2. So move on to the next prime number after 2. After 2, what do you have? 3. Check if it is divisible by 3. So 27 is divisible by 3, right? So 3 times 9 is 27. Again, 3 times 3, 3 times 1. The moment you get 1, you stop. Okay? Multiply all of these. So 2 multiplied with 2, multiplied with 3, multiplied with 3, multiplied with 3, you get 108. That's all. If I were to write this in terms of a power, 2 multiplied with 2, I can write it like 2 power 2. And 3 multiplied with 3, I can write it like 3 power 3. So this is going to be the prime factorized form of 108. Yes. Can't be write 1. There's no use in writing 1, right? Because 1 is going to be divisible by 1 itself. So 1, 1, 1, 1, 1, 1, it goes on and on and on. And moreover, you know this. Any number multiplied by 1, you get the number itself. So it makes no sense to write 1. All right? So you've understood what prime factorization is, right? You start with the first prime number and then keep dividing till you reach 1. The moment you get 1, you stop. All right, cool. Now let's see how we can prime factorize this number here, 1980. So this is going to be a big number, yeah? Let's see what the answer is going to be. 1980. All right. So first thing, what am I going to do? I'm going to check if this is divisible by 2 or not. So I divide it by 2 and see. So 1980 when divided by 2, how much do you get? This is 2 times 9, 18, 19. Okay, 1 is the remainder, 2 times 9, 0. So I get 990. 990, again it is going to be divisible by 2. So this is going to be 2 times 4, 8, 2 times 9, 2 times 5. So this is 495. Yes? One is the multiplicative identity. Yes. Is there an easy way to find prime factors of large numbers? No. This is how you've got to proceed. Okay? There will be other methods that you would be learning to figure out LCM, HCF in maybe 9th or 10th grade, but till you are in, I believe, 8th grade, prime factorization is what you need to stick with. Okay, 0 is the additive identity. Well done. You guys have the answer as well. All right, cool. So this is going to be divisible by 3 as per your answers. So 3 times 1, 3 times 6, 18, 3 times 5. Again, this is divisible by 3, 3 times 5, 3 times 5. This is 5 times 11, and this is going to be 11 times 1. Okay, so I multiply all of these numbers. Yes, and when I do that, I get this. And if I want to write it in a proper way, this is 2 power 2 multiplied with 3 power 2 multiplied with 5 power 1 multiplied with 11 power 1. Since there are 2 2's, 2 power 2. Since there are 2 3's, 3 power 2. 1 5, 1 11. 173 a prime number. I believe it is. Actually, Shashwat, there is a method in which we can check if a number is prime or not, but it's beyond the scope of today's session, so I'm not going to discuss that. But yes, don't worry about it. There is a method to check if a bigger number is prime or not. Okay, we'll do a Menti quiz after we have, studied some concepts. Cool, so we've understood this, yes, because this was really important. Okay, so we've understood prime factorization. Now what we are going to do here is very important. Using prime factorization, we will learn how to calculate LCM and HCF. Okay, now for that, I'm just going to explain you this first. All right, now let's suppose the first number is A. This is 2 power 3 multiplied with 3 power 2 multiplied with 5 power 1 multiplied with 7 power 2. All right, let's suppose this is A. And then you have B, which is 2 power 1 multiplied with 3 power 3 multiplied with 5 power 2 multiplied with 7 power 1. Now don't look at the examples that you have here, 60 and 90. Focus on the examples that I have given you here. So A, let's say after prime factorization you get this, and then B, after prime factorization you get this. I want the HCF of A and B. Okay, please focus, because if you understand this, you've understood today's session, because we've come a long way, right? We've studied what factors are, what multiples are, what prime, composite. We've looked at all the definitions. We've seen prime factorization as well. So all of that was done because to make you understand this. All right, come on, focus on this now. So we want to find HCF of A and B. Let me also write that down. HCF of A and B. Now to find the HCF, you will look at the lowest power of prime factor. I will also mention that down. Look for the lowest power of prime factor. All right. Now, between 2 power 3, 2 power 1, let's take a different color to highlight the powers. The power here is 3, the power here is 1. Which is the smaller number? 1 is smaller or 3 is smaller? Is 1 smaller or 2 smaller? Sorry, 3 smaller. Ashish, this is the technique to figure out HCF. Okay, 1 is smaller, right? So I will be taking this, 2 power 1. Okay, multiplied by. Now move on to the next prime factor. Which is the next prime factor here? 3. Now is 3 power 2 smaller or 3 power 3 smaller? 3 power 2 smaller or 3 power 3 smaller? 3 power 2 is smaller, right? So I will pick 3 power 2. Now, 5 power 1 smaller or 5 power 2 smaller? 5 power 1 is smaller, so I'll pick 5 power 1. And then among 7 power 2 and 7 power 1, 7 power 1 is the smaller one, so I will pick 7 power 1. This is going to be the HCF, that's it. Okay, so this is going to be 2 times 9, 18, 5 times 7, 35. I'm going to leave the calculations to you. This is how you figure out the... Okay, Shashank says she's not understanding it. Okay, let me just take another example. Let's suppose I write A here as 2 power 5 multiplied with 3 power 2. And B is going to be 2 power 4 multiplied with 3 power 5. Alright, I want to find out the HCF. Because You've got to learn HCF using prime factorization, right? So how you figure out the HCF is, you take the lowest powered prime factor, because between 2 power 4 and 2 power 5, 2 power 4 is smaller, right? 2 power 5 is obviously bigger than 2 power 4. So you take 2 power 4. And between 3 power 2 and 3 power 5, 3 power 2 is smaller. So you take 3 power 2. That's it. This is going to be the HCF. Okay? Alright, Arka says the question is to find the HCF, so we take the larger number. Arka, I will explain you in some other session as to why we are taking the lowest power. Okay? We're not taking the larger number. We're taking the lowest powered prime factor, because factors divide. For now, I want you guys to understand the technique. The logic behind it we will cover later. Okay? No, you have to understand the reasoning. I agree with you here. You have to understand as to why we take the lower power, why we take the bigger power. Today what I want you to do is, I want you to take small bites at a time. You know, understand it well. First understand the technique, then you will understand why the lowest power. Okay? Come on. So HCF is what now? What did I tell you for HCF? Now if I give you any random numbers of 60 and 90, first 60 is what? 2 power 2 multiplied with 3 power 1 multiplied with 5 power 1. Similarly 90 will be what? 2 power 1 multiplied with 3 power 2 multiplied with 5 power 1. So now, how do we calculate the HCF? HCF is going to be what? HCF of 60 and 90? Lowest powered prime factor. So between 2 power 2 and 2 power 1, 2 power 1 is the smaller one. So I write 2 power 1. Between 3 power 1 and 3 power 2, 3 power 1 is the smaller one. So I write 3 power 1. 5 power 1, 5 power 1, both are equal. So I can go ahead and write 5 power 1, because there's no lower, no higher. This is going to be the HCF. 2 times 3, 6. 6 times 5, 30. So this is the faster way of calculating HCF using the technique of prime factorization. Okay, what is power? Okay, power simply means this, you know, 2 times 2 times 2. You write it like 2 to the power 3, right? So this number that you write on top of 3 is called the power. Okay, have you understood what HCF is? 30 is the HCF, yes. Difference between highest common factor, lowest common multiple. We'll summarize this. Highest common factor. Highest, I'm sure you guys know what the word is. Common also you know it. Factor, you have studied it. All right, come on, let's figure out the manual way of figuring out HCF. Okay, now I'm going to rub all of this out because I need some space to work through this. Okay, factors of 24. Come on, type it in the comments. What are factors of 24? That's a good question. That's a good question. Type it in the comments. What are factors of 24? I'm explaining this once again so that you guys are easily able to understand this as well. Factors of 24. 1, 2, 3, 4, 6, 8, 12, 24. Well done. 1, 2, 3, 4, 6, 8, 12, 24. These are all the factors of 24. Now tell me factors of, let's say 30. Tell me factors of 30 now. You guys have given the correct answer. Factors of 24 are 1, 2, 3, 4, 6, 8, 12, 24. In a similar way, tell me factors of 30 now. I will also start doing something. 1 is a factor, 2 is a factor, 3 is a factor, 4 is not a factor of 30, but you have 5, you have 6, and then what else do you have? 10 is a factor, and then 15 is a factor, and then 30 is a factor. These are factors of 24, these are factors of 30. Very good. Now, let's focus on the word highest common factor. Okay? These are all factors, right? First, tell me what are common factors. I'm going to circle the common factors now. What color do I take? This one. Okay, circle the common factors. 1 is common, 2 is common, 3 is common. What else is common? 6 is common. Apart from these, are there any common factors between them? The common factors are 1, 2, 3, 6. These are common factors of 24 and 30, right? Among these common factors, You have to pick the highest. Which is the highest among 1, 2, 3, 6? 6 is the highest. So 6 is the highest common factor. That's it. Have we understood now? What is highest common factor? That was a good question. I was focused a little bit on showing you the technique of calculating it. That concept came next, but I'm sure you've understood this now. So factors of 24 are these, factors of 30 are these, common factors are these, and then the highest one out of the common factors is 6. Is that clear now? What is HCF? Yes? Shall we, in a similar way, let's try to understand what LCM is. All right? Okay, LCM. These are going to be some multiples of 60. And these are going to be multiples of 90. Or if we were to talk about 12 and 30, no problem. Multiples of 12. What are multiples of 12? 12 times 1, 12, 12 times 2, 24, 12 times 3, 36, 12 times 4, 48, 12 times 5, 60, then 72, then what is 84, the list goes on and on and on. You've seen it, multiples are infinite. In a similar way, multiples of, let's say, 15, what are multiples of 15 going to be? 15 times 1, 15, 15 times 2, 30, 15 times 3, 45, 60, 75, 90, again they're going to go on and on and on. Yeah, 60, as you can see, is the common multiple which is common and which is smallest, because as you can see here, how many common multiples are there? Look, between 60 and 90, 180 is common, and then 360 is common. There will be some other common multiples as well. Infinite common multiples will be there. But the lowest among them happens to be 180. Okay? Now, I have a trick question for you. Okay? Can you tell me the lowest common factor? Lowest common factor. What is the lowest common factor going to be? Of 12, 15 or 60, 90, whatever. Any number. What is the lowest common factor going to be? Well done, Abhishek. The lowest common factor is going to be 1. Every time. Excuse me. Doesn't matter what the numbers are, the lowest common factor is always going to be 1, right? Lowest common factor is always 1. This is the reason why they don't ask you lowest common factor, because doesn't matter what the numbers are, lowest common factor is always 1. And now you understand why highest common factor is something they ask you, right? Because lowest common factor is always 1. Now you've studied the lowest common multiple, right? Can you tell me what the highest common multiple is going to be? Highest common multiple. Can you tell me the highest common multiple of 60 and 90? Very good. Infinite. Well done. Who's that? Ayush. Infinite. So now, I think you've understood a very important concept, that why they don't ask you lowest common factor, because it's always going to be 1 no matter what the numbers are, and why they don't ask you highest common multiple, because it's going to be infinite. Alright, this is the reason why you are asked the highest common factor. You've seen the logical breakdown of it as well, and why they ask you the lowest common multiple. Okay, have you understood these two here? Yes, very good, very good. Alright, now I'm gonna go back to the last part where we figured this out. Yeah, and I'm going to erase this. And I told you something, right? For calculating the highest common factor, you take the lowest power. To calculate LCM, you will take the highest power. It's in fact opposite to the way we see it, right? You take the highest power of prime factor for LCM, and you take the lowest powered prime factor for HCF. Like if I ask you what is the LCM of 60 and 90, LCM is going to be out of 2 power 2, 2 power 1, which is the bigger one. 2 power 2 is the bigger one. Out of 3 power 1, 3 square, which is the bigger one. 3 square is the bigger one. Both of these are the same any which way. So we leave it as it is. So this is going to be 4 times 9 times 5. That's it. So just remember this. For LCM, you take the highest power of prime factor. It is mentioned here. You will get the notes of this on the Telegram channel. And for HCF, you take the lowest power of prime factor. And you've understood in a logical way as to what factors are, what multiples are, and why they don't ask you lowest common multiple and why they don't ask you the highest, why they don't ask you highest common multiple and the lowest common factor. Okay, Aditya says you made the notes. Well done, my friend. Okay, so moving on from this, that's it for today's session on LCM and HCF. Rest of it we will cover up in the other session. So this was just meant to be a basic session for you. So just some practice. Let's figure out LCM of 48 and 102. Okay, 48. First, let's go ahead, prime factorize 48. So it's going to be divisible by 2. So 2 times 24. Come on, let's do this together. Let's prime factorize 48. 2 times 12, 2 times 6, 2 times 3, 3 times 1. All right, so 48 here is going to be 2 power 4 multiplied with 3 power 1. I hope I'm right. Yes, Arka, the notes would be shared on the Telegram channel, nothing to worry. In a similar way, 102, let's prime factorize 102. This is going to be 2 times 5, 2 times 1, 3 times 17, and then what is this going to be? Yeah, 17 times 1. So now 102 is 2 power 1 multiplied with 3 power 1 multiplied with 17 to the power 1. Okay, this was simple. Yeah. Now, how do we find LCM? For LCM, we take the highest powered prime factor. Okay, so 2 power 1, 2 power 4, which is bigger? 2 power 4 is bigger, so I write 2 power 4. 3 power 1, 3 power 1, both are the same, so I write 3 power 1. 17, there is nothing in 48, so I'll take this down. That's it. So this is going to be LCM, simple. Okay, so just need to remember this. For HCF, we take the lowest power of prime factor. For LCM, we take the highest power of prime factor. It's in fact opposite. Lowest means you take highest, highest means you take lowest. Okay, exponent, all right, 2 power 4, this is called exponent. I'm sorry if I'm using words that you guys are not familiar with, bear with me on that, please. All right, so I'm sure you've understood that. Moving on now. Okay, this is going to be an activity that you guys can perform and let us know in the comments as to what happens. And you will observe this really important property. Product of two numbers is going to be equal to the product of their LCM and HCF, and there'll be plenty of questions even in 9th grade and 10th grade that you will be able to do with this property. Okay, so calculate LCM and HCF of 18 and 30, multiply them, see what answer you get. Multiply 18 and 30, you will see that both will be equal. Okay, so perform this activity, and then this is going to be the summary for today's session. Look, we've seen what factors are and multiples are, no doubt with this. We've seen prime numbers, composite numbers. We've gone through the technique of prime factorization. We've seen what HCF is, and we've seen what LCM is. That's it. Like Abhishek has summarized that. Oh, you've done this in class 5. Well done. Cool. And this is going to be another trick that you guys can perform. Think of a 2-digit number. It can be anything, like let's say 37. Reverse the digits. When you reverse it, you get 73. Add the newly formed number with the original number. So 37 plus 73, you will get something, okay? And then divide this by 11, and you will always see that there is not going to be any remainder. So perform this trick as well and let us know how you found that in the comments down below. And lastly, guys, this is going to be the homework. Okay, 2 milk tankers contain 450 liters, 600 liters of milk. Find the maximum capacity of a container which can measure the milk of both the tankers when using an exact number of times. So you simply have to decide if this is going to revolve around HCF or LCM. The hint that I can give you here is whenever there is division going on, highest common factor. Whenever there is a process which keeps multiplying itself, it is going to be the lowest common multiple. That's it. Okay, so you can try this homework question, let us know. And lastly, again, the link to these packages could be found in the descriptions box as well. So in case you're not a premium student, you can try the classes out. I'm sure you will love them. All right, because come on, personal attention, one-on-one guidance, extra classes, you can choose your own timings. It's mapped to the school curriculum. Where else can you find these awesome advantages, right? So link is there in the descriptions box. Make sure you try that out. And of course, again, join the Telegram channel as well for the session notes. Got you covered, of course. There will be a free trial class, lastly. And that's it, guys. This is the end of the session. In case you've liked the content, please hit the like button, share it with your friends, and subscribe to the channel in case you're not. Okay, Rishabh says, sir, I study in class 7 and I confused in exponent and powers. No problem, Rishabh. I'll explain you that then and there. Look, let's say 5 multiplied with 5 multiplied with 5. How many times are you multiplying 5? You're multiplying 5 with itself 3 times. So you write 5 like this, right? 5, you write a small power. This is what is power, that's all. Or it's also called exponent, both the same. Okay, thank you. You've been amazing as usual. I'll catch up with you next time with another session from the same topic. Till that time, please remember to take care of yourself. And as I said, if you still haven't subscribed, please make sure you subscribe and then share it with your friends, like it. It'll mean a lot to us. Thank you for your time. You take care of yourself. Bye-bye.